We got another vehicle that came in today. This one, the customer, one of our dealers, actually brought in, and they have an issue where the car will not move, and it's throwing a code on the controller, just a fault code, which we'll have to pull up in a second. And they've already put a new controller in this vehicle once. It was diagnosed as having a bad controller, and then from their preliminary checks, it looked like they probably still had the same exact faults. So we're going to dig in a little deeper and try to figure out why we're having a reoccurring issue, or is there something else causing this issue. But this is one of our Star EV sport model vehicles. It does have the 1268 controller and a DC motor. So we'll dive in real quick. Let's see what kind of codes we have on it and see where we can start out at. So now we got our Curtis handheld programmer hooked up. This is our 1313 programmer. We're going to check and see which codes we have on the controller. So on here, we'll actually come down to our diagnostic screen, and then we'll check our present errors. Don't have a present error currently, but we haven't tried moving the vehicle. The two we have: field missing and speed sensor fault. Both of these can be related. And looking at the controller, it does have a status light that's blinking on it. The status light is blinking a 1 blink and then 3 blinks. So that's a 1-3 code or a 13 code, and that is a speed sensor code as well. So we'll dive in. Let's see. We clear the fault out. We'll try to move the vehicle. Does that fault come up as a present fault? Then we'll make sure we're focusing on the right fault before we start. So we're going to go and check our codes out. We had the field missing and speed sensor fault. When I hit clear all and cleared it out, the speed sensor fault came back up, which tells me this probably means it's a current fault now, a present error. Yeah, it is. So now it is showing as a present error. Let's try operating the vehicle and see if it does anything. Because sometimes the cars will move with a speed sensor fault, but they'll move slowly. Alright, we heard the contactor click, which is a good sign for the rest of the signals, but the car is not moving, so it kind of tells me immediately that the controller thinks it's operating, but it's not actually outputting power. So we'll dive into that. Let's see if we're getting any kind of power out from the controller itself. So we have another video we did recently, and that vehicle also had a speed sensor fault, but the car didn't move. And we had to diagnose it and found out it just had a faulty connection at a speed sensor. What's different between this car and the other car is this vehicle is not moving. When we pressed the gas pedal a minute ago, we heard that main contactor click and pulled in, but the car does not move no matter how much throttle pedal or input we give it on the throttle signal. But we're still getting a speed sensor fault. So what makes those two different is when one moves, at least we know the controller is working in the car that moves. In this car, this instance, we don't know the controller is working. And the reason we're still getting the speed sensor fault in this controller example is it thinks it is. We heard that click. It thinks it's going to be outputting power, and we're going to verify that in a second if it is or not. But the motor is not moving. So only input it has back to see if it actually operated correctly is to see if the motor speed sensor worked. And since it doesn't see any input back from that speed sensor, it's assuming that the speed sensor is faulty. It can also be that the motor is faulty or the controller is faulty. So that's why we're going to start running a little bit more on the motor and controller side instead of starting on the speed sensor side in this vehicle, based on that this vehicle does not move when you hit the gas pedal. So now we're going to check our field circuit. That's the first thing we're going to check from the output from our controller. To do that, we're going to hook up our voltmeter, and there's an F1 and F2 terminals back here. F1, this is you'll see a smaller gauge red wire coming across. This comes from the motor over. We're going to hook up to it with a positive lead on our voltmeter, and then on the negative lead on our voltmeter, we're going to come to F2, which is field 2, and there's a black wire attached to it, and we got little alligator clips to lock it on there so you stay nice and secure. We have our voltmeter set to our voltage point. We should be expecting roughly 7 to 10 volts whenever we press the gas pedal. So we'll watch this for an actual output from the controller. But also we need to know on our controller, we can't watch our field voltage, but we can watch our field current. So I'm going to select this one, and you press right arrow to dive in and get a single view on the screen. So our field current. And I want to see when we press the gas pedal, this number should go up. It's already showing kind of high already. There's a little bit of an issue. But when we press it, it should go up. And it should kind of give us an indication that there's current passing. We should see voltage as well show up. So if the controller thinks it's doing something, but we're not actually getting it, that would give us an indication of a controller issue. So now we're going to press the gas pedal. We'll hear the contactor click. And we'll watch the handheld for current, and we'll see if we get voltage reading on the voltmeter. We did notice something a little odd. Our field current is showing really high. A minute ago it was like in the 79. Now it's showing like in the hundreds, a little over 100. We did a test on it just to see if it would zero out after we pressed the gas pedal and let off. It did come up kind of high, and then it slowly started dropping back down, which is kind of an odd signal for us to be getting it. So something does appear to be incorrect with that circuit already. But let's press the gas pedal and let's see what reading we get. We are going to go full throttle. You do need to make sure that the vehicle is jacked up and somewhere safe. The rear tires need to be off the ground just in case the vehicle does take off. And make sure nobody's standing in front of the vehicle before you do this. So we'll go full throttle. It's saying 39 amps. We are not getting any voltage reading. Nothing significant enough. We're going to need at least that 5 or 6 volts to get the thing moving. Let's try it one more time. You can see our current is dropping. Go full throttle. Still nothing, no voltage. Now we're going to test our armature circuit for our motor. We've now moved our leads to where they're on the B plus on the motor controller, and then they're also on the M minus on the controller. So that'd be the far right hand larger terminal, and then in the middle larger terminal. We also have our handheld connected. We got it now on, instead of on field current, we're now on armature current. So we can monitor that on the handheld, what it thinks it's actually doing, what it's measuring internally. And we have our voltmeter beside it, hooked up on those leads on the motor, or on the controller for the motor. We're going to try the pedal again. You'll hear it click. We get armature current. Or, I'm sorry, we do not get armature current. We get armature voltage. No power. So we got voltage going up to it through the contactor, but not out. Since we're not getting any movement out of this vehicle when we press the throttle, we need to check the motor, the output from the controller to the motor, and how the motor is reacting. And there's 2 circuits we need to do in order to do that. We need to check our armature circuit, and we need to check our field circuit. Our armature circuit is where we're going to be consuming most of our current through the motor. That is actually what's going through the brushes, and then in the motor. And then there's the field circuit, which is the magnetic coils that are on the motor. We need a small current and voltage on those for the armature to operate as well. So we're going to show you real quick how to check those 2 circuits and see if they're operating correctly, and give you an idea of what window they should be operating at. Since we are having a little bit of an issue with the armature circuit, we do want to run a quick check just to make sure we don't have a main contactor issue. We're not getting a weak battery pack signal to the armature. So I've now connected our B plus terminal to our positive lead, and then our B minus, which is now the far left hand side, is on our negative. And I'm gonna hit the gas pedal. You'll hear the contactor pull in, and then we should see our voltage come up on our voltmeter, and it should be roughly battery pack voltage. So 47 volts, a little low, but we're good. That's not the 13 we got a little while ago. So 47 is actually good. And the voltage, you'll hear it click out. When you do, you'll actually be able to monitor the capacitor voltage in the controller dropping off. So that's why you'll see your voltage numbers drop. But I think we're good. I think our contactor looks good so far, and battery pack looks good enough for us we should be operating. So now we're going to dig in a little more into the motor side, because we know the controller is not outputting the signals it should be and the power to the motor. But since the customer told us that this car does have a brand new controller on it, we still could have a bad controller. Could be a reman new controller, could be bad, or we actually could have a bad motor. I want to make sure we're not going to put another controller on and have another bad controller. So let's check the motor first. We're going to start with checking our field circuit on our motor first. So we've reconnected our connections for our field circuit, which was our F1 and our F2. At this point, polarity, it does not matter. You could do either red and black on either one. We just want to make sure we're on the smaller leads, F1 and then F2. Our voltmeter is still hooked up. We still have it on voltage right now, and this is what we were checking on a little while earlier. But now we want to come up to our resistance, which is the little upside down horseshoe, ohm signal. We want to come up, go to ohms, 0.08. This should roughly be about 0.7 to 1 ohm. So this tells me that the field circuit seems to be good. We don't see a dead short, or a dead open or a dead short in this field circuit. So now we'll check it. We still need to check it to the case, and then we'll also check the armature. So now we're going to start checking out our field circuit in our motor. I want to make sure this field circuit is not shorted out to the case, which means like the wire for the field circuit has not broken down from being overheated or having too much current ran through it, and it hasn't shorted to where it's touching the metal case of the motor itself. That would result in a dead short, which would blow the controller out if it tried to apply power and current to it. So we want to make sure we don't have that scenario before we try to put a new controller on this vehicle. So we've moved our leads over now. So we got our F1 is hooked to our positive lead on the meter still. And then we went to a case with our black lead, which actually we're doing to frame. And we're going to check our resistance. So we're still on ohms. And you'll see the M, which means mega ohms. So this is very, very high resistance. And in this case, we're still getting out of limits. Generally, anything in the mega ohm reading or higher. So if you even have 1 mega ohm or 7 mega ohms or OL, means that we do not have, or it's very, very, very high resistance from the motor field circuit to the case, which is a good sign that it's not going to short out. We're not going to have an issue with this motor here. So it looks like we're in good shape. So now we'll move on. Let's check the armature circuit as well. So now we're going to check out our armature circuit. We've now moved our leads over. So now we're back to our B plus terminal, which is also our A1, armature 1 on our motor. And then our motor negative is the middle terminal on the controller. That's actually going to be our armature 2 on our motor, which should be labeled as an A2. We want to check the resistance through the circuit. These two should be in direct contact, so we should see a very, very low resistance reading through here. In our case, and we don't want to make that necessarily a dead zero, but we got 0.2 ohms resistance. It can be beneficial to try to move the vehicle around and make sure that resistance reading is not changing. You might want to go a full revolution of the motor. We're checking the brushes, and we're checking the commutator in the motor. Make sure there's no damage inside of there. If you start seeing this number jump to like OL again on the meter, that can be an indication of an issue in that circuit where there is no continuity through the motor. In this case, we've moved it around. It looks good. We're getting 0.2. Seems like we have no issue on the armature side itself. Let's check now to case on armature, make sure there's no issues on that. So now we've moved our lead over. I kept the A1 connection from our motor, which is also B plus on the controller. And now I moved my motor negative lead over to our frame. We're just using a frame bolt here. Just connect it right off the same frame where the rear end is. Essentially what we're checking here is for continuity between the armature lead, which is going through the motor, and the case. So now we're looking to see if there's possibly a brush issue connected to case. Or commutator failure somewhere, but mega ohms is still reading, and it's OL, so no resistance here. It's still open circuit, so there's either super, super high resistance or no continuity going through the motor armature to case. So now we finished our test with the motor. The motor looks like in good shape. We don't see any issues that might possibly cause a short. I think we probably only have a controller issue for this vehicle. Which is odd because they've already said they replaced this controller before. So we're going to go ahead and get another controller, and we're swapping it into this vehicle. And then we're going to retest it and see if we get any different kind of results out of the motor and the controller itself with the new controller. So we're going to start replacing the controller in the vehicle now. The first thing we have to do always, especially when you're dealing with a live voltage on these, and it's a high current live voltage, is just go ahead and disconnect the batteries first. So we're going to just disconnect. You can go main positive, main negative. Either one. All we really need to do is take off one of these. So one of these is a charging cable, and one of them is our main battery cable. So we got our controller installed now. We went ahead and we tested it out. We got ahead programmed it first. Got the battery hooked back up. We went to go test it out. Still didn't get any movement out of the wheels on this car or out of the motor. So we started checking the signals again, the same way we were before. Now, whenever we press the gas, we're going to watch on the handheld armature current, field current, RMPWM, field to PWM. So the PWM should range from 0 to 100. 100% means they're 100% power output at that point. And the current is just how much power that is. So when we press the throttle, we got it in forward, press the throttle down now. We don't get movement, but we get amperage, and we do get a voltage reading. And right now our voltmeter is hooked up to our armature side. And then we also tested our field side just now too, and it has the same thing. We're getting close to the 7-8 volts, like we were mentioning we expect to see normally. So even though we tested the motor for resistance, we tested it on the field and armature on both sides, and it seemed to be correct, there still seems to be an issue. So at that point, we're going to stop. We're going to disconnect this, undo the battery so we don't mess anything up with the controller while everything's working normally. And then we're going to have to take the motor out, and we can bench test it or we can replace it. I think what we're going to do is a bench test, and we'll see how that works. So we've got the motor out now. And we looked at the first input side, output side. Looked fairly good. A little rusty, but it wasn't too bad. So we went ahead. We took off the service band, where you can get rid of the brush to get access to the brushes. And what we noticed is, first we rolled it over. We started getting lots of pieces. Metals melted, ends, carbon brushes melted. This brush is cracked. So this motor's had a complete failure. You see a piece of wire was loose. This is the end. It looks like the failure was on. And melted off. So this arcing is probably what caused the issue. This is where the actual failure occurred, and it probably did burn the controller out. And if there was a temporary connection here, this might have burned out the new controller they had put on before. It may have been a good enough connection through here, even though it was busted, for us to get the reading we were getting a little while ago. So that was a good reason why we took it apart, inspected it, tried to figure out where the issue was. So what we'll do, we got the new motor. So I'll put a new motor in it. Then we got the new controller in, and we'll try it again. All right, so now we got the motor changed out on the vehicle. Let's do a quick test. We hooked the battery back up, turn the run tow switch back on. Key on, get power. Let's put it in forward. Gas pedal, we'll get a solenoid click. And we notice that the vehicle moves in reverse. So let's try it in reverse now. And as the vehicle moves forward, which means we got the direction backwards. We have two options. We could swap the wires on the motor, on the field wires, or we can change the field direction swap parameter in the controller. We'll swap it off to on. Now the direction is switched. Yesterday we finished up by changing the parameter in the controller for swapping the field direction. We didn't get to finish everything up yesterday, but we got everything buttoned up this morning. Now we're back on it. Let's test it again. Let's make sure that our parameter change made the adjustment we want. So now we're in forward. Vehicle moves forward like it's supposed to. In reverse, moves like it's supposed to. A little peppy, but yeah. So we got it changed now. That parameter swapped our directions, so we didn't have to go down and change the actual wires. The controller in this car was bad. We did have no output out of the controller when we tested, and then we found the problem in the motor where the brushes were actually damaged. On several brushes were damaged. And so we got a new motor in the car, and those are our two issues. So now we're back to operating normal.